So let's see if somebody comes as well.
So
0 attendees. Oh, people are joining. All right, let's give it like, I think, a minute or two more for people to join, and then let's start. I wonder if there's like an easy way to open this up for like everybody so that everybody could talk.
yeah, I don't know.
In the past, we've done it so that actually it's like a normal Zoom call, and then people just join. And
when it's a normal Zoom, then yeah, people can kind of speak. This way they can just chat.
Mm-hmm. Yeah, I think that's even the best way, in my opinion, is like everybody on the same call, basically. All right. So let's give it another minute. Actually, I can already display the agenda. All right, let's start. Welcome everybody to the Enterprise Serverless webinar co-hosted with Webiny. Today we'll have 3 talks. It will take about an hour. The first talk is from Sven Hamad, and the talk will be about challenges with building serverless applications. Next up will be yours truly, me, about building and monitoring large-scale serverless applications and kind of observability and all of that good stuff. And the last one will be Tobias Schmidt about securing enterprise-grade serverless applications. So with this, I'll hand it over to Sven. One last thing, you can ask questions at any time using the chat, and I will try to moderate it into the talks, find a good place to ask questions. So over to you, Sven.
All right, let's do this. So let me just share. There we go. And I'm gonna go here. Awesome. Well, welcome everyone. Glad to have you here. So hopefully in the next couple of minutes, we'll be able to provide some knowledge around serverless, be that on how to build applications, how to monitor, how to secure them. So in my talk, I'm going to focus on some of the challenges with building. I'm going to start high level, and I'm going to keep most of the talk there because people come with different knowledge sets. Serverless is still a fairly new thing. So I'm going to keep things quite generic, but if you want me to go deeper into any of those topics, just give me a ping on the chat and I'm happy to kind of dive deeper. Okay, so who am I? Well, I'm one of the founders of Webiny. Webiny is a serverless content management system that also allows you to build APIs, GraphQL APIs on top, as well as serverless full stack applications. I'm a developer by trade, but lately I'm more focused on running Webiny as a business. And if you want to chat with me besides Zoom, follow up afterwards, you can find me on my Twitter. So to kick things off, now, why serverless? What's the whole story around serverless? Why does serverless matter? Well, at Webiny, we believe that serverless is the future of development. It's the next step in the evolution of infrastructure. So here on the right-hand side, you can see that evolution curve, which is from the physical servers when we had to provision them and kind of wait for them for months to arrive before we could use them, to virtual machines and containers that are now available within seconds or minutes. But the key there is the aspect that you as a developer what are the parts that you need to manage, right? With serverless, the only thing we manage is the application code, the business logic, right? Everything else is abstracted away and it's managed for us by the cloud vendor, right? Now, that is kind of the, let's say, off-the-shelf explanation of serverless, but how that plays in practice is quite interesting. First of all, one of the biggest changes that serverless introduces is consumption-based pricing. That means that you pay per how many functions you ran or how many database calls you did, right? Regardless of how you provision those. With that in mind, well, just by moving to that consumption-based pricing, we never overpay, we never over-provision, we never under-provision as well, but we stop paying for things we don't use, right? And that's a big chunk of the cost we're actually paying. In some research, there's like proof that cost saving is up to 80% cheaper than virtual machines. And because many of the layers of running your application are now managed by the cloud vendor themselves, you don't need to invest so many hours of DevOps time to manage networking, operating systems, containers, and things like that. You can save up to 60%. So just these two numbers provide a tremendous cost savings to others, right? And how serverless is built, those are services that you interact through an API with, right? When I want to access my database, I send an API call to write data or to read data. But behind that API, it's actually a fault-tolerant infrastructure, right? It's self-healing. We do not need to build all that tolerance anymore ourselves. And that is a massive win that serverless brings to the table. And again, similar to that fault tolerancy, that infrastructure scales in and out within milliseconds usually. So it is quite elastic and follows our usage patterns. But the main difference, besides the cost and that we're interacting with the API, is that the application that we built in the past, we could have easily migrated from a physical server to a VM, from a VM to a container. And the reason why we were able to do that is because from the application's point of view, is the same environment, just the virtualization technology is slightly different, right? But the application would run. But that same application, it can't be migrated from those environments into serverless. Serverless requires us to rebuild, re-architect, re-engineer our application in a totally different way. So serverless is kind of a breaking change for the infrastructure. And that is where the first serverless challenge comes. It pretty much means that the things we knew about building applications, some of them, they still relate to serverless, but others don't. And we need to kind of rebuild our knowledge. And with that, of course, when we need to learn a ton of new things comes the added complexity. Now, I'm going to go through 5 challenges in my talk about specifically around serverless. And the first challenge is that it kind of relates to the previous slide. It's a different development experience. And it's different in a couple of ways. I pointed out only 3 here, but there's many more. But the top ones are, first of all, there's no local development environment. You can't run serverless services locally. Sure, there are kind of solutions that half emulate some of those things, but you don't want to test your applications against them because you can't get the same limits, the same networking characteristics that you will get in the cloud. And that might heavily influence how your application behaves. You just can't do serverless locally. The other thing is, because everything happens in the cloud, it's like so much harder to attach a listener to our code to send us back the logs, the errors, and things like that. All of this thing now happens in the cloud and stays in the cloud, and then we have to find ways to retrieve it locally and to figure out which log line fits to our actual execution. So there's a lot of time and energy that is required to do that properly. And then, again, going back to the previous slide, a lot of the existing stuff we knew about architecting those applications, it doesn't apply anymore in the serverless world. We have to rebuild that knowledge in a different way for us. So a couple of tips on how to get around some of these challenges. Well, in this particular case, so in case of the local development, embrace the cloud native development. That there's now solutions that can watch your code locally. When you save it, it uploads the code into the cloud, executes it, returns back, streams back the response, and all of that happens within a second or two, right? So it kind of gets close to that local experience, but not quite, but at least it's cloud native. You're not relying on some emulations that don't give you that confidence to build proper applications and test them on top. For testing and debugging, there's modern solutions, Dashbird, one of them being, and you're going to hear more about them. But the whole monitoring and testing, debugging, yeah, there's now better solutions than just kind of looking at the logs, especially pulling them manually from the cloud. And as I mentioned before, like you need to rebuild your knowledge through blog posts, talking to community, joining different community channels, and slowly starting. If you're new to serverless, slowly start with the smaller projects before you move to the large ones. Now, the next challenge is one that I saw people often stumble upon is they, like when you Google serverless development framework, things like that, and I'm talking about serverless in general and framework in general, there's a lot of solutions there that tell you, hey, we allow you to, we are a serverless development framework, or using us, you can build serverless applications. Most of these solutions, they are here. They just help you define your infrastructure and deploy it. They do not help you build your applications, because building an application takes much more, and that's from you'll get generic tools like React, Webpack, Node, whatever language you use, but then securing your application, testing, deploying and monitoring. Why I'm mentioning these, because some of these are very specific how you're going to approach them, because you're now building a serverless solution. For example, deploying your CI/CD pipelines might be provisioning too many serverless services, and AWS has low limits on them. So you need to work around how do you have parts of your application with a long-lived infrastructure, and also some services do not like spikes in demand. How do you build your application and your CI/CD pipelines around that? Testing is also challenging. In certain cases, you'll find some quirks if you need to hammer DynamoDB from a specific IP in certain cases. There's so many detail in there that you will unravel when you start actually building serverless applications. Fortunately, there's no tip here, but just like don't be fooled by the fact that, hey, I can just spin up a server, an API using serverless framework. Yeah, but the moment you start actually building your whole backend logic, there's going to be many more challenges that are going to come that serverless is going to impose on you. Fortunately, don't have a solution for this. It's just something as part of a journey you're going to have to go through. Now, going to a bit more concrete challenges. One is microservices architecture. Microservices work great if you have virtual machines or containers. When you have serverless, I would be very, very careful about that. So let's say you have 3 services, the user service, product, and checkout. And to render a page, you need to hit all 3 to get all the appropriate data to be able to display the whole page to the user. With microservices, like you would have each of these services deployed in its own container, right? And that works if it's a long-lived container. But with Lambda functions in this particular case, it's a bit challenging, because you will face more cold starts if you break it down too much. Also, for example, let's say a product service has to also call the user service on the back end. And let's say an API request comes to the API gateway. There's a 2-second cold start for the product service to load, or 1 second. Product service loads, but then needs to call the user service and waits another 2 seconds, and then retrieves back to the user. So having that chain of lambdas, one calling each other, it's death to your performance. Like that is a bad pattern when it comes to services, when it comes to serverless. You need to think really carefully about how you break those things, what are those calls and services you need to render a specific page. You might want to bundle them in a monolithic Lambda. I know monolith might seem like a dirty word to developers, but it's not. If it serves the end user, if it serves the purpose. How you bundle the code and work in teams, all of that can still be very granular, and then just bundle it as a single package to a single Lambda. Because you're going to see that breaking down too much, it's going to penalize your performance significantly. One other thing to mention here is a similar pattern you might find if you use federated GraphQL schemas, where you have one, let's say, Lambda running your GraphQL server, and then each of the schema objects is another Lambda, and then they call each other to stitch the schema together. That, if you have a lot of the objects and your schema being pretty big, that's gonna come with such a massive performance hit, you'll just give up on serverless. While it's not the fault of serverless here, it's not the right pattern to be used, right? Now, another challenge is that serverless comes with a vendor lock-in, and yes, it does, right? Serverless, unlike, again, virtual machines or containers, which are just virtualized environments, serverless is not. Serverless, from a perspective of a developer, is a service that we interact through an API. And between each of the cloud vendors, that API works differently, behaves differently, and even the cloud vendors themselves tell you to build and use their services in a different way. So sticking to one vendor and building everything on top of serverless, it's going to make it super hard to migrate to another vendor down the line. Now, how to get around that? Well, there's two things. Well, one might be that you just don't want to. Maybe your organization is dedicated to run on AWS for the next 5 years, and you're perfectly happy with that. And if you are, you should not fight it. You should just use the best that that cloud has to offer. Do not satisfy yourself with the lowest common denominator, that you don't use the advanced capabilities of some of the services just because in 5 years you might want to migrate, right? So that's one option. The other option is, if you do think you will want to migrate in a year or two and you want to kind of build in some of the abstraction layers, there's ways around it, but of course they'll come at a price, either a price that you will need to maintain that solution, a price that you will need to build that solution, right? So it's gonna come with an impact. But some things are like super easy to do, and some services you might wanna kind of build your own. An example would be, for example, AppSync. If you're running a GraphQL API, super easy to actually run one in a Lambda instead of using AppSync. And by running it in a Lambda, you're going to have better control over it, how it behaves, how it caches, how it integrates on the security layer with different IDPs and things like that. So some of those services, it works perfectly. For others, it doesn't, right? If you want to use DynamoDB, well, DynamoDB, like everybody teaches you, there's a SQL type of a database and no NoSQL type of a database, and that Dynamo is like a NoSQL. In practice, no, there's a third layer there, and that third layer is DynamoDB because it behaves totally different. And once you're locked into such a database, migration is still possible, but it's much, much harder. And the final challenge I'm going to mention is related to what we saw in the market, is that some of the enterprises take this step-by-step approach of migrating from either VMs or sometimes on-premise solutions to serverless, right? And a step-by-step approach means that you have this massive monolith and you chip away one part of the, let's say, API, and migrate that part to the cloud, to the serverless services. And then you take another, and that's how you run through the migration. It is a best practice, but be wary of some of the pitfalls. One of them being, for example, communicating with the database. Let's say you have an older solution and it uses MongoDB, right? MongoDB is not a serverless, let's say, serverless compatible database. What I mean by that, MongoDB doesn't come with an HTTP API. There's ways to put one in front of it, but it doesn't come by default. It uses TCP/IP-based connection system, meaning that if a client wants to open a connection, it has to use the TCP/IP protocol instead of the HTTP high layer protocol. Now, the challenge with TCP/IP and specifically Lambda functions, well, you can establish that connection, but Lambda functions get destroyed, the new ones get spun up, and that cycle repeats constantly. The problem there is that the way the Lambda function gets destroyed, it doesn't tear down the TCP/IP connection properly, in this case with MongoDB. And MongoDB thinks that there's still a live client behind that connection. Well, there's not. It's actually a zombie connection. Does the zombies here. With couple of cycles of happening, like having those functions spin up and tear down, you're going to end up having a ton of zombie connections. And eventually MongoDB won't be able to release new connections and new clients won't be able to connect. But that doesn't mean only that your Lambda functions can't connect to MongoDB, but your legacy solution also can't access the same database because the Lambda functions brought it down. So having that, what I'm trying to say here is having that step-by-step approach, reevaluate your infrastructure pieces, your communication layers and protocols, what I use, and ensure that you do protect some of those outdated or not serverless compatible infrastructure pieces. In case of MongoDB, you can put a proxy in front of it, but there's others. There can be storage layers that require such a connection type of a system. So just make sure you build a plan and fully understand all of the moving pieces of what it means to pick a specific database in this case, as well as run through a step-by-step migration, ensuring that the legacy system is properly protected. Now, these are the challenges, right? And just want to talk quickly about one of the potential solutions to make your life easier with serverless, and that is Webiny. So Webiny is a serverless content management system, but you have the ability to build applications with it. And Webiny is fully serverless. It handles all of these steps for you, but it doesn't reinvent the wheel. Webiny integrates with these tools and provides a common layer with all of the serverless best practices, with the serverless best practices architecture. And like Webiny is completely free and open source, so it's super easy to use, get started, start dabbling with serverless, because through Webiny, you already have a working API, a working content management system. It's open source, so you can see under the hood how we architect and then build some of these things and pick up some of those best practices. It's much easier to get started with a ready-made solution than just building one from scratch. There's going to be a lot of trial and error, and it's going to take a lot of time to get it right. I know we took that approach and cost us a lot, but you live, you learn. So that was it for my talk. So I see there's a couple of questions here. I can answer those in the chat, and
maybe we could discuss them like right now as well.
Okay.
Also, there's a question. Can you talk about the last slide again?
So let me see. How do you balance? I'm going to just go top to the bottom. It's going to be easier. How do you balance splitting into multiple lambdas? Any rule of thumb? So the best rule of thumb is to picture the user journey. So the end consumer, because that is the person that is affected the most. And what are those pages that the end consumer is visiting, and how those web pages interact with your API, right? What are those calls that those pages do? And if you see you need to reach 4 or 5 services just to render that one page, I would consider putting all of those services under one roof. To give you an example, for example, in Webiny, we've got a massive API. Like the GraphQL schema is very big. And we have everything packed in a single lambda. We've tried like having 6, 7 lambdas, didn't work. We tried having 2 or 3 lambdas. It was okay. A monolithic lambda for an API worked perfectly, because the cold start can be minimized by proper bundling, removing, like there's GraphQL servers besides Apollo. Apollo is a bloatware when it comes to servers because it impacts your cold start significantly, but there's thinner options for how to run a GraphQL server in a Lambda, and those won't impact your cold starts, even if you have a big schema. And then over time, like if you hit a function many times, it's warm. And yeah, I would just kind of stepping back. I would just start from the end user, start with the end user, and I will I would, as a best practice, I would start actually with a monolithic Lambda and maybe over time see if there is a reason to break it down, if you have a problem with it, which I believe you won't. So that's kind of related to that. This is a Webiny specific one. So the course headers on Webiny are, well, in the latest release are actually implemented for you by default, and we have a security best practice for the course headers there. If you want to change that, you can give us a ping on the community Slack, and we will we'll show you a reference and how to build a plugin to add that core headers. Slide 13. So slide 13 is an overview of the Webiny solution, right? So Webiny is not your typical, let's say, a CMS or a typical development framework. It is a serverless application that is built on this massive foundation that allows you to build APIs, full stack applications using scaffolds. And on top of that foundation, we built CMS capabilities. Webiny comes with a page builder, with a headless CMS, with a form builder, and file manager. So out of the box, you get a massive solution that you can expand, customize. And Webiny handles all of these layers for you. On the infrastructure side, by default, it integrates with Pulumi, and it uses Pulumi to deploy your Webiny instances in CI/CD environments to multiple stages, dev, prod, whatever you want. The whole application layer is based on JavaScript, so Node and React. The security by default, Webiny is an enterprise-grade solution, and by default, it integrates with Cognito, and we have a fully working single sign-on with Okta, so you can put SAML, anything you want behind Okta, and integrate it into enterprise environments. And the testing is fully done through Jest and Cypress. Cypress is running in CI/CD for us, and the whole CI/CD Webiny scaffolds the CI/CD environment for you if you want inside GitHub Actions, so you don't need to build one. And trust me, just this task alone is going to take like a couple of weeks to do properly. And then monitoring, like Webiny can integrate with all of the standard monitoring solutions because it's a Lambda layer that comes on top, or just a JavaScript library that you integrate. And then because of the CMS capabilities, so with Webiny, you can pretty much replace solutions like Webflow and Contentful and build headless full stack applications, pages, landing pages, forms in a serverless environment without the need to rebuild your whole application and do many other things. Let's see. So when you talk to the databases with Lambda, you should drop the connection with the request and responses. Also, you do not want to drop the connection to the database. Closing the connection comes with a penalty. Opening a connection comes with a penalty. The connection should always be open when you use the TCP/IP connection system. Otherwise, you'll be just opening, closing connections all the time. The database doesn't like that, and your application is going to have a performance hit. So, I mean, no TCP/IP-based connection database actually kind of tells you to close a TCP/IP connection. It's always the keep alive is always the general practice. We, specifically to MongoDB, we are in talks with their product owners, and Mongo is working on solving that problem. We gave them a lot of logs and a lot of research we made for that specific issue. So hopefully in one of the next releases, Mongo will tackle that one. Well, Peter, I'm happy to chat more on the database side, and maybe I can share one blog post.
I think that maybe the attendees don't see the Peter writing you.
Oh, okay, so yeah, there's more. There's more stuff coming in the chat on the database side. So I've just shared one link in terms of the all of the details about the TCP/IP connection problem. But we did, like I said, a lot of tests here. So hopefully you guys will find that valuable. Okay, I don't see any more questions coming in. Cool.
Awesome. Thank you so much, Sven.
There you go.
Awesome. So next up, me. Can you see my screen?
Yep.
Yes, awesome. So I'm going to be talking about building and monitoring large-scale serverless applications. As you know, my name is Taavi. I'm the CEO and co-founder of Dashbird. I've been developing applications and programming for over 14 years, 15 years even now, or 16. And been working on different serverless applications since 2016, built many before starting Dashbird, but also obviously Dashbird is completely serverless and I don't develop it anymore. I don't program anymore, but yes. So today, two things that I want to cover and the reason I want to cover these things is because we see the most of kind of problems with those areas, and these are the things that people are struggling with the most, the things that are slowing organizations down when they're adopting serverless, and kind of the biggest things to get right in my opinion. So I would say that the kind of hello world serverless setup is broken. We see a lot of organizations kind of starting to build on serverless. They take the most kind of simplest setup in the serverless framework. They deploy a hello world application, and then that's the state where they leave the development processes. And once you kind of start kind of building and kind of doing it on a daily basis, extending it to your team, it can really slow you down. And specifically, there's three things that we see that are happening. The feedback loop is slow. So, it's hard to develop locally, what Sven mentioned as well. Deployments are kind of slow. Environments can be kind of limited and kind of you can't, maybe you share one development stage in AWS that everyone is using. So there's a lot of hassle, a lot of kind of complexity, it seems at first. The other thing we see is that when you have a serverless project of any kind of size, it usually takes a bit more time to onboard new people than you might see on like, container-based server-centric applications, simply because the logic of the applications is usually distributed and you have to understand like tons of moving pieces at the same time, and that takes time. And also I would say like the tooling is new. It takes time to learn. And the third thing is when you're actively developing, debugging, no matter kind of what you're using, kind of in the local environment, understanding applications is tricky. Understanding what they are doing, how the requests are flowing. If something breaks, once you deploy something into a QA environment or a development environment, and that's a really kind of tricky thing to get right, and it always takes time. So I would say that the number one thing to do is to take some time off the initial enthusiasm and then invest in building the kind of the flow early on. Make sure the iteration speed is quick. Make sure you organize your resources quickly, or like the best way possible and the simplest way possible, and make sure you know how to debug and troubleshoot your application actually. So we'll go like quickly to go over those things in a bit more detail. Build a good local development environment. There's another slide about this. The other thing is know your AWS services. So there's actually tons of power and tons of kind of maturity built into the AWS offerings is it like, CloudWatch, X-Ray, Cloud9, the console itself, the SDKs. There's a lot of things you can do with it. I don't know the most of these, and or maybe I do by now, but it took me years to learn. I should have done it sooner, and I definitely kind of wasted time on this at some point, not knowing the ins and outs. Yeah, I think the other kind of thing is like what we struggled with early on, and what we see a lot of the customers struggle is that when you're not organizing your resources, your AWS accounts the right way. A lot of customers only have one AWS account where everything is there, like the staging, the test, the QA, like tens of versions of the same serverless application, and then like hundreds of microservices. Really hard to understand, a lot of risk, complex CI/CD, lot of security issues with that. Like the third thing, detecting problems. So once you deploy kind of a new version of your code into even a development environment or a staging environment, what we see is people using a lot of time roaming around in the console, in the UI, in CloudWatch, in X-Ray, not really understanding what's going on, spending a lot of time there. So you need to kind of find a way to effectively do that as well. I think the most important thing actually is speeding up the feedback loop. So when you're developing, when your team is developing an application or some new feature, how can you make it so that when somebody writes a line of code that they want to test, they get feedback the quickest? I think at my first time in my first company that I was working at, building on serverless, hours were wasted every day, just kind of waiting to test something in an AWS environment. That was in 2016, admittedly. So a lot of the tooling that exists now and the processes weren't available. But so there was basically three things that you can do. We did the first two. One of the things we did was, let's say you're developing a function, you run it locally, but all of the services that is communicating are mapped to a cloud environment, so into your staging or development environment. So that's one thing we do. It's like super easy to kind of just write code, have a command line code or like command that executes it, and then you get the result straight away. You can change it in the next second, the code, and then try it again. The other thing was actually everything was local. So you could go onto a plane and develop serverless there, which was really tricky to set up. So emulating DynamoDB locally, for example, or whatever, that's super tricky. But if you're able to do it, it's quite good. I don't really recommend it, or like for some use cases, but not all. Because it might not be the same as actual AWS services. But if you're able to do it, much faster development times. And the latest kind of thing is that you can actually edit code live. So you can have your own everything set up in the cloud. You can use Cloud9 or Visual Studio or lots of other development environments or kind of code editors are doing this now. There's like the logging as well there. So you get the logs back. You can like do different types of things. So that's a good way to approach it as well. But it's super important to get the feedback loop up. I think two things that will save you. Don't deploy after each code change the entire, like don't do like serverless framework deploy. That's really going to teach other developers not to do it as well. It's a major time sink. Even individual function deployments can sometimes take time. So try to avoid that. And the other thing is that really helped us was that at first, when you do a deploy, you basically, to see how it's working, you need to go to AWS and like dig in CloudWatch and in the UI and kind of figure out what's going on. That's a major time sink. There's ways to do that in the console. There's other tools for that. So try to avoid that as much as you can, but not always can you avoid it. There's another kind of slide about what slows down people in AWS or using AWS. I would say number one is not learning the ins and outs in Dashbird, for example. Whoever comes into the team, they need to go through the Cloud Guru course on like the basic AWS and kind of the more detailed courses as well. and they need to do an AWS Solutions Architect certificate. And that takes time in the beginning, but it really saves a lot of time in the future. If you know what you can do with CloudWatch, with X-Ray, with the console, they are really powerful, but they're super hard to use. So invest in that, it will save you time. Another part is we see a lot of customers overusing the UI or like the web console of AWS. It's very tricky to use quickly and efficiently. It's not meant for kind of day-to-day debugging at all. And there's better alternatives in the command line to kind of tail logs if you need to, or to look at metrics. There's different services that do it. If you stick in AWS, you have 15 developers in your organization, you're gonna lose days in a week. And I would say that the last thing that we've seen a lot and like kind of experience as well is that when you kind of don't invest time into when you kind of have weird setups in how you manage your resources, like not having separate AWS environments for like separate things, not having clean posture management, resources are configured all over the place, IAM policies are weird, complex CI/CD pipelines. So spend time kind of learning what are the right ways to do it, and kind of look at the different resources in AWS, talk to maybe solutions architects, or just like browse the community websites. There's tons of knowledge and materials about it in the web. So yeah, what we recommend, play around with tutorials and documentation a lot. That saves time later. Yeah, I think this is some of the things I already covered in the next slide by speaking. But yeah, you can use the console and third-party services, and yeah, invest time to operational excellence early on. Cool. So the next kind of chunk of my talk is about when you're already going, you're developing, you have efficient ways of producing code and producing serverless infrastructure ready, and then you kind of reach a scale where you actually have users, it's in production. So there's the next kind of big problem that we see. And kind of the idea, or kind of the main principle of that problem is that when you kind of reach hundreds of resources that are being used by the end user, the complexity grows quickly, because you have like a lot of surface area to cover in terms of the data that your application is producing. And there's a lot of risk in all of those different resources, and to manage that risk is really important. So just an example, this is our infrastructure, I think like a year or two ago. Right now it's significantly bigger, but you get the idea, like services all over the place, a lot of communication. So yeah, to kind of be more concrete, there's two main things that we see that users are struggling with. Amount of data is the first one, and kind of general know-how team-wide about what's happening in the system, and kind of knowing the system in and out. Like a quick example why this is so complex is that every resource you have in the cloud has like 5 or more metrics, and it produces logs and tracing data. It has a configuration. You can have those resources across regions, across AWS accounts, and you end up with this kind of unimaginable amount of data that is being produced all of the time. It's really hard to understand and observe. The second part is that basically the known and unknown failures. Every point in your system is a potential point of failure. Lambdas can have code exceptions, timeouts, whatever. APIs can time out. Any resource basically can be configured in a way that makes it not work. You can have like API limits, concurrency limit, throughput limits, misconfiguration, delays. So that's kind of the reality. When you put something into production, you're never going to know how the users are going to actually use it and what's going to happen. The good news, however, is that all of the managed services in AWS or in any kind of cloud provider are what we call observable. That means that like you can understand the inner state of all of those services by looking at the outputs. So all of the data is actually there. 99% of the relevant information already exists in AWS in some way or another, whether it's CloudWatch logs, in X-ray traces, in CloudWatch metrics, in configurations, in changes of the configuration, in like access logs, whatever, but it's usually there. You can figure it out through AWS. The problem is it takes huge amounts of time. It's super complex, and it takes time to discover that there's failures, and it takes time to understand the root cause of those failures. So two kind of things that we think are super important to achieve for monitoring. First one is kind of being able to interrogate the data that's already in the cloud efficiently. This is the first thing that we do as a platform, and that's one of the main reasons why Dashbird exists. So there's other tools that also try to do this. Our approach is mainly based around centralization and making the data accessible and like navigable. So we try to break down the silos between logs and metrics and traces, meaning if there's a kind of a Lambda execution, then we can connect that to an X-ray trace. We can extract the metadata, we can understand what happened before and after, and we can give you kind of a breakdown of the situation. And we can do that across regions, across accounts. And we also try to give you a way to kind of like look at the data from different angles. So you can look at the metrics and then go to the logs, or you can look at the logs and see what kind of metrics are associated with it, or kind of how a request flows from one side to the other. And we try to give you kind of an end-to-end view from account to transaction level. And we do that by also by being really elastic. So you can like push as much data into the system, and like it will always work. We're automatically ingesting all of the data. All of the resource changes will be automatically covered in the platform. The second part that we try to do really well is defending the customer against known and unknown failures. So we see the problem in large applications being twofold. Identifying failures are kind of what they call mean time to discover. Means that if something happens across the application, to know about it at all. Worst case scenario is that you hear about it from your customers, or you discover it by just like looking at the website at some point. So the first thing that we do is we try to minimize the time it takes to discover issues. The second part is we try to point you to the root cause as quickly as possible. In other words, mean time to resolution. So that's the other kind of metric that we're really focused on as a platform, and that's what we aim to do for the customers. So our approach to monitoring, to recap, there's actually 3 pillars. I didn't cover the last one. We bring all of the data together, we make it simple to understand, and there's like as little extra overhead for developers as possible. We detect the failures, we make sure that your application doesn't break, or if it does, for you to have the ability to react. And we manage also the posture and security of your application by scanning it in real time and giving you a list of insights and things to do. So this is the last slide before the thank you slide. everything I talked about just now is can be worded as operational excellence, and it takes a lot of time and effort to actually achieve it across the organization. And on top of the things I already mentioned, I would say the well-architected framework and the serverless lens of that is super useful, really eye-opening, and I think that's another material that you should be looking at. And what we've kind of utilized in the past a lot is AWS solution architects. Like if you're kind of selecting between services to use, or kind of how to architect an application, all of those kinds of questions you might have, chances are they've seen it working in some other company. They can kind of give you the best advice. So use that. Don't be the guinea pig for everything you want to test. And yeah, there's a growing ecosystem of different tools that Sven already showed in multiple slides. So those tools are there for a reason, and some of them are really useful. So I think to win with serverless, definitely play around with those, see if you like any of them. And thank you. I don't know if we have any questions. I don't see one in the Slack right now. So over to you, Toby.
Yeah, thank you, Taavi. Then I will share my screen. So, oops, wrong button. So last topic for today, I guess I just have 10 minutes, but it will be about securing your serverless architectures. I'm Toby. I'm an independent cloud consultant, just like recently quit my full-time job at some consultancy after working for like 5 years at some German car manufacturing, like working a lot with AWS, especially with Lambda, like building services from scratch and like doing all the horrible mistakes one can imagine. So yeah, there's a lot of experience going on. And I'm also a developer advocate at Dashbird since a few months. And I'm also trying to bootstrap my own product on AWS. So yeah, there's a lot of going on. So what I will talk about is like some general things I always like to mention about serverless in the first place. Then a quick introduction about all the security touch points in your basic serverless application where you have to think about. Then some like general concepts about storing and retrieving secrets, what you have to think about IAM, about roles, policies, and all the advanced constructs. Then a little bit about auditing and monitoring, like because if there's some security issue popping up and you don't know about it, then like it's the worst thing that can happen. Then a little bit about web threats and about the mitigations, and a quick summary in the end. So yeah, first things first, because like it's some general misconceptions going on about serverless. Like serverless is pay-per-use, which doesn't immediately imply that it's always low cost. You have to optimize for costs. The same is for availability and elasticity. You have to design for reliability. Like there comes something out of the box, but you can create your architecture that bad that it will be like way less reliability than just running a container and some VM. And like the same thing applies for all the other topics like performance efficiency or operational excellence, and especially also for security. Like not everything is secure by default just because you don't have to manage your security groups or your ports. Everything is managed by IAM, but you are reliable for it. So you have to design for security. Like the first thing I'm always advising is please don't just run with one AWS account. Please just use several AWS accounts, like one for production, one for staging. It's like the minimum setup for some serious projects. You should probably even go for like isolated accounts per developer, because it's like way easier to test things out, and you won't probably break your pre-production environment easily, and like you're not paying in advance if you're just running serverless resources, because like most of the stuff is pay-per-use. So having some additional resources in other accounts like won't impact your bill as it would be if you would run some ECS clusters, for example. So that's always the first thing I would advise. Then if we look at some default serverless architecture, we're having a lot we have to think about. Like in the first place, we still have to think about some cross-site scripting or denial of service attacks, or SQL injections, or privilege escalations, or even data loss or data corruption. That's why we should make heavy use of everything which comes out of the box by AWS, like especially the web application firewall, setting our IAM rules, policies and roles properly, and making use of AWS config and AWS CloudTrail. And like what's also important to know, like AWS rapidly evolves, and like just keeping track about all the new features like is probably really difficult. And if I look just in the last month, I think AWS also announced this public endpoint support for Lambda functions. So you're not even need to have an API gateway in front of your functions to make it just publicly available, which could be like a huge security issue for your apps. So yeah, you have to keep track about a lot of stuff if you want to maintain good security in applications. So then first thing is about storing and retrieving secrets. Good advice is to always go for IAM where possible, because like it's way less error prone. Like you can't lose any secrets, because in general, there aren't any secrets. Everything is just maintained by execution roles and by permission policies. So this is way less prone to human errors, because like most of the security flaws I faced in the last years were always determined by some human mistakes. Like it wasn't some design flaw in the application. It was always like committing some secret into GitHub or logging out some access token somewhere. So please always rely on IAM where possible. Then if you have to store some secrets, use some secure storage like the secrets manager, or DynamoDB also perfectly fits, because it's a key value store and it's encrypted by default. What I really like about the secrets manager is you can easily automate secrets rotation by writing some Lambda function, which like removes a lot of operational burdens. That's really cool. Then what's also probably advisable is to keep your function small. Like by small, I mean it should be grouped by the needed access rights. So you can always assign the minimal privileges to your functions. As Sven said in the beginning, like this has to meet your demands for your application, because like the more functions you have, the more you have to fight with all the cold starts you will face. So you should always keep that in mind, but it's generally a good advice to keep your functions like grouped by the needed access rights. If you have some critical payment processing in some Lambda function, this should probably be separated and not running in some other code. So then for IAM, like I think it's the most complete and probably also the most complex service of AWS, because you can do so much with it, but you will also like struggle a lot with it in the beginning, as I did. like generally a good advice is to like minimal use of wildcards. So if you're creating a new policy for your Lambda functions, please never just do the DynamoDB with the star for all resources, because it's not a good way of assigning your rights for this function. Always make it as minimal as possible by like selecting the actions that are really required by your Lambda function. If it just needs to read some table entries, then please just assign the query item action, and always directly assign the ARN from your resource and just don't use wildcards. Then what's also really neat is you can also extend your policies by using conditions to making like a more fine-grained window for when the policy actually applies. Like in the example, you can see, for example, there's some condition for the leading keys of your DynamoDB items. So the leading keys must match the user ID from your federated web identity. So your Lambda function is bound to just query items which match for the identified user at the current time. Like you can do a lot with that actually. Then there's also something which is probably really unknown. You can also define some pass roles, which like defines which roles are allowed to be passed by a given identity, which is also really cool. Then there's also this construct of permission boundary policies, which I found quite useful in the past. You can apply some additional policies which are always restricting the effective permissions of a role. So for example, if you're accidentally assigning like a way too broad policy to some Lambda function, but your boundary policy have some general rules that it could, for example, just access S3 buckets with some generic prefix, for example, then the boundary policy will always restrict these permissions, regardless of what the execution policy says. That's some really cool concept to easily separate domains if they're in the same AWS account. Then like one more thing about OAuth2 and OpenID Connect. If you have some identity provider, it really, really easily integrates with your serverless application, because you can just assign a JWT authorizer to your API gateway. And you can, for example, if you're using the HTTP gateway, it's even more awesome because there's the default JWT authorizer, which you can just use by configuring your well-known /OpenID configuration endpoint from an identity provider, and the API gateway with the Lambda function will like take care of validating the token and also extracting all the claims which are inside your token. For example, the account ID or all the other identity-specific information the token is carrying to your Lambda function. So your Lambda function is automatically bound to this user context, and you can also like forward it to all other functions. And you don't have to maintain any code or even write your own code in the first place. Then for auditing and monitoring, yes, as I said in the beginning, like if you are not aware that there are some security issues happening in your account, then it's basically the worst thing that can happen. So make heavy use of what's already in the box for AWS. Like make use of the web application firewall and API gateway, because there's a lot in the box. Actually, there's throttling or rate limiting. You can do geo restrictions. You have some protection for cross-site scripting and denial of services. You can also use usage plans. So you can configure some limits based on client IDs or client API keys, which is really cool. CloudTrail is also a good idea because you can monitor all the changes to your infrastructure. And if there's some suspicious updates, you can like do direct mitigations via some attached Lambda functions, or just send notifications via Slack so you're aware of what's going on. What's also really neat is to use CloudTrail data events, for example, to track changes for your DynamoDB items. Like you can send out Slack notifications if some unexpected role or identity modifies entries in your DynamoDB table. Like that's really, really cool. Then also make use of AWS config, because we can like easily set up auditing rules or configurations rules for your serverless functions. So if there's some changes which you wouldn't expect, like for example, the logging is disabled for your Lambda function, which sound really suspicious, you can get notified about this immediately. Also, you can also attach some direct mitigations via Lambda functions. Then what I would love to know in the beginning, it really pays off to use some more advanced tools like Dashbird. The well-architected lens is really, really awesome because it gives you a lot of guidelines on the do's and don'ts for serverless, also regarding security. So it's really worth to use, especially in the beginning where you're a lot of trial and errors and you don't really know what you're doing, because like serverless is a completely new topic, and it really pays off. And you can also like try it out for the first 1 million invocations, so you don't even pay for anything. Then yeah, for the threats and mitigations, like I said in the beginning, like your responsibilities with serverless drop a lot, because you don't have to care about any hardware, OS, or container vulnerabilities, but your application threat model is still the same. It's still a web application, and you will face cross-site scripting and SQL injections, and you are responsible for it. So yeah, please think about this for cross-site scripting. Yeah, escape your dynamic content properly, or use content security policies. Sanitize everything correctly for the SQL injections. Like as always, never trust the user's input, and always use compiled SQL statements. And then yeah, for the summary, like make the most out of AIM, because it's an awesome service and you can really, really restrict access very fine-grained. Probably keep your functions small and group them by the needed access rights. Make use of the advanced constructs like conditions and pass role or permission boundaries. Always think about redundant layers of security. So probably don't just rely on the API gateway for authorizing your request. Probably also doing in the functions that are coming downstream. Then keep your code simple, as clean and possible, like no secrets in code. Probably use static code analysis tools to find issues before committing something. Keep your dependencies as minimal as possible. That also helps in keeping a small code start small. And yeah, take advantage of AWS Toolbox and probably use third-party tools like Dashbirds, and always think about the common web threats, because yeah, they also apply for your serverless architecture. Yeah, that's already it. Thank you for listening. And if there are any questions, we can talk about that.
Awesome. Thank you so much. I don't think we have questions. Not that I've noticed. So cool. I guess that's it. Thank you so much, both of you, and thank you all for listening. This was a pleasure. Yeah, wish you a good start of the day or end of the day, wherever you might be. And awesome. Thank you so much. See ya.
Thank you all.
Thank you. Bye-bye.